All right, this little video is going to talk about pH and what it is. And so first thing we need to talk about is the auto-ionization of water. So in the acid and base video, we saw that water, while we normally think of it as neutral, can be an acid or a base depending on what it's reacting with. And so water, two of them can react with each other where one proton gets transferred to one and leaving behind hydroxide on the other. And this, of course, is an equilibrium between hydronium and hydroxide. All right, so it's a very, very important chemical reaction. As a matter of fact, almost everything in this chapter is based on this. Now, this has an equilibrium constant. So you write the equilibrium constant. It has a special name, Kw. I'll let you guess what W stands for. It's products, H3O plus, and hydroxide, divided by a liquid, which is by definition 1 or folded into the equilibrium constant. So that's it. This is the only constant I want you to know. Kw for water is 1 times 10 to the minus 14. Okay, and so I'm going to explain why I want you to know that number. So, for example, in neutral water, it turns out if you do an ice table, then the amount of H3O plus and hydroxide are the same because they're coming from the same two waters, and it's a one-to-one relationship. So if these are the same, some number x, we get a simple equation that x squared equals 1 times 10 to the minus 7 molar. Okay, technically activity, but we're going to say the concentration is 1 times 10 to the minus 7 molar. And so now that's the amount of H3O plus and the amount of hydroxide. Now, note this is only true for water. If we have an acid or a base in the solution, this is not going to be definitely true. If we have an acid, we'll have more H3O plus, and if we have a base, we'll have more hydroxide. But the product is 1 times 10 to the minus 14. So what that tells us is if we throw an acid into water, that will determine the H3O plus concentration, and then this equilibrium will determine the hydroxide concentration based on the hydronium concentration from our acid. So anyhow, so H3O plus is 1 times 10 to the minus 7. Well, people don't like working with real small numbers, and so we're going to look at the power of the concentration, and the power of the concentration is minus 7. So we could define a logarithmic scale where the log would be minus 7. Well, people don't like negative numbers, so instead of dealing with negative exponents, we're going to change the sign. So the definition of pH is minus the log, base 10 of the hydronium, which we'll call H plus because I want to emphasize this H is this H plus. It's not anything else. All right, and so the pH, the minus log of 10 to the minus 7, pH equals 7. Okay, and everybody knows the pH of pure water should be 7 as long as there's nothing else dissolved in there. Now, if you take water out of your tap, you're not going to get pH 7. It's going to have carbon dioxide and other things dissolved in it. It's not going to be pH 7. Now, there's another concept is what is the power of the hydroxide concentration? It's the same idea, it's just hydroxide instead of H3O plus. And so POH is exactly the same idea. It's just minus log of the hydroxide. So OH, OH. So POH is also 7. All right, so that's the case for neutral water. Okay, so now let's look at a strong acid. Okay, so what? So first of all, I'm going to give you a little question. In 1 molar hydrochloric acid, what is the concentration of HCl? The answer is, well, let's take a look. Feel free to add a water and make this HCl plus if you wish. And so the initial change and the final, 1, 0, and 0. So it starts out at 1. Since it's a strong acid, there is none left. So the answer is 0. Okay? So you cannot take the concentration of HCl to get the pH of HCl. Besides which, pH is minus log of H plus, not HCl. So we've got to figure out what that is. Okay, so notice that we didn't use minus x plus x plus x because we actually know the mystery number x. And it happens to be all of the hydrochloric acid that you dissolve. All right, and so now H plus the log of 1 is 0, and minus 0 is 0, and so the pH is 0. You can actually have a negative pH if the H plus concentration goes above 1 molar. You'll get negative pHs. All right, and so be careful that you realize that just because something's written so-and-so molar on the bottle does not mean that's the concentration of the thing. It's actually in solution. All right, so in the next video, we're going to talk about different case, which is a weak acid.